In this video on demand, we're going to look at attaining universal connectivity on a per-link basis. We're going to approach this topic, and the topic overall is attaining universal connectivity, and we're going to do this over 3 link types. In this VOD, we're going to look at the simplest of all links in an internetwork, that is a point-to-point link. In a subsequent VOD, we're going to take a look at point-to-multipoint links. We consider this an evolutionary extension of the point-to-point link concept, and we'll be looking at frame relay for an example of point-to-multipoint. We'll also take a look at universal connectivity on a multi-access link, and it's no surprise that we'll be using switched Ethernet for that video on demand. Let's start with a simple point-to-point interface using the default Cisco HDLC encapsulation. We could ensure we're running this default encapsulation by resetting the interface to default using the command default interface serial 1/0 in global configuration mode. I've already done that on R2 for this demonstration. One interesting aspect in performing this configuration is the fact that the interface serial 1/0 here on R2 that we're going to begin working with doesn't have a MAC address. And if we're going to generate, as we know the router will, a link local address and use a modified EUI format for the interface ID, where is the MAC address going to come from? Well, as I'm about to prove to you, it's going to come from a LAN interface. The router operating system literally borrows the MAC from a LAN for the creation of the address. Let's go ahead and do a debug IPv6 neighbor discovery, one of our favorite commands whenever we're manipulating addresses on the router. And let's go ahead and go to the interface serial 1/0 and let's assign an IPv6 address. The address we're going to assign is 2001:1001:2/64. We should see some debug output. First of all, our prefix is added, and then we do a neighbor solicitation for the link local address that was generated. We do duplicate address detection, and we find out that this link local address will be just fine. It is unique on the link. Notice we run through the similar process for our global address, and we assure that the global address is indeed unique on the link. Now, if we do a show IPv6 interface serial 1/0 and we focus in on our link local address, we'll see that it was created just fine even though we didn't have a MAC address. Where did that MAC address come from? Well, I have suggested to you that it came from the fast Ethernet or the LAN interface on this router. Let's check. Do show interface fast Ethernet 0/0, and I want to include the reference of an address. This is a really neat show command modifier that says, okay, don't show me the entire show command, just show me any lines which include ADDR. And by the way, that is case sensitive, the ADDR. And here we can see the address, the MAC address assigned to that interface. CC01-025C0000. If you look at the link layer address, let me do show IPv6 interface serial 1/0 pipe include link local. Here we got nicely displayed for us the link local address. When you compare it to the MAC address, you see that yes indeed, this MAC address was used to create the modified host interface portion here. We know it adds the FFFE. We can see the C0 that ends this address. We see the C that starts this address, the C01. That's borrowed from this field. So they do some manipulation on this MAC address, but trust me, it is this MAC address that was used for this interface ID calculation. Very interesting stuff. The EUI64 host ID uses the Fast Ethernet 0/0 MAC address to create the Serial Interfaces Link Local host ID. And when we do a global unicast address as we did here, that same MAC address is going to be utilized. To avoid any confusion, it's generally recommended that you go ahead and apply your own link local address that will be easier for you to identify. All you got to do this is say IPv6 address FE80::2, for example. I'm on router 2, so I'll end the interface ID with 2. And then you just say it's a link local address. We'll go ahead and do all the unique testing for this. It's going to indeed be unique on the circuit. And now we have a link local address that is much easier for us to work with. In fact, let me rerun that earlier command where we look at just the link local output, and here we can see our new link local address on this interface is FE80::2. Much easier for us to work with. Now let's briefly discuss configuring IPv6 over a PPP interface. We're going to change our encapsulation now to PPP. I'll simply say encap PPP, and we should see the link fail. The link is going to fail because we have an encapsulation mismatch. So let me go over to R1. Let's go to the serial 1/0 interface. And let's set PPP is the encapsulation there as well. If we come back to R2, we should see a status message here any moment, and there it is, indicating the link is back up, and we'll go through all the neighbor discoveries and neighbor solicitations and duplicate address detections on the link. If we go ahead and take a look at, let's get back to privilege mode, let's say show interface serial 1/0, what we should see to confirm we're using PPP is we should see encapsulation set to PPP, and then the particular network control protocol that should be in use, look at this, IPv6-CP. So they have a network control protocol designed for IPv6, and we can see it there clearly. One other interesting note for configuring IPv6 over a PPP connection is that unlike for IPv4, there is no peer neighbor route issue with IPv6. In IPv4, this PPP peer route feature generates a host route that can create connectivity issues, but good news, there is no such issues with configuring IPv6 over a PPP link. Let's wrap up our discussion on configuring IPv6 over physical point-to-point connections. We've so far examined two options for the physical point-to-point interfaces, the proprietary HDLC encapsulation and the open standard PPP encapsulation. There are a number of logical point-to-point interface options. Many of them involve tunnel interfaces, and they'll be covered later in subsequent VODs. Before we leave the point-to-point interfaces, I do want to make two brief points. Both relate to link local addresses. Number one, how do you ping a link local address? And number two, how can I configure a point-to-point interface, or can I configure a point-to-point interface using only link local addresses? Well, let's answer both of these questions. A point-to-point link local address is pinged on a point-to-point interface like any other link local address would be pinged. You have to specify both the destination link local address and then the specific exit interface. Let's try it. Over on R2, we set up a very easy to remember link local address. So let me go over to R1 and let me ping it. Remember, it was FE80::2. And remember that these addresses in IPv6 are not case sensitive. When I go to ping the link local address, the router says, wait a minute, I need to know out which interface you need to send the traffic to this particular link. And we say, okay, it is serial 1/0. You cannot abbreviate this. You cannot say S1/0. In the output interface field, you must use the longhand reference of the interface. Why? Just don't know. That's how they programmed it. So here we can see we have successfully pinged the link local address that we created on R2. Now let's answer the second question related to configuring a point-to-point interface with only a link local address. Can we do this? Can we skip the global unicast addresses altogether? The answer is, you sure can. You can configure link local addresses exclusively on your interfaces, but please remember when you do this, you cannot reach that interface from a remote network. Many times this is not going to be a problem with our point-to-point interfaces, since they are usually simply router-to-router connections. Look at this illustration. Here we have simple router-to-router point-to-point connections over this backbone, and those could be link local address interfaces only. We'd put routable addresses elsewhere in our topology where we need to access those addresses from some other network. I hope you've enjoyed this video on demand dealing with attaining universal connectivity on a per-link basis, and here we obviously focused on the point-to-point link structure. I think you're really going to enjoy subsequent VODs, if you like this one, that deal with attaining universal connectivity on multi-access and point-to-multipoint links.